In this video, we're going to look at another example of basic integration. A ball is thrown downward with a speed of 10 meters per second from the edge of a cliff 100 meters above the ground. Find the equation for the height of the ball t seconds later. We choose the upwards direction to be positive and the downwards direction to be negative. And since the force of gravity is downwards, the acceleration of the ball must also be negative. And the initial velocity of the ball is also negative since the ball is thrown downwards. Alright, we know the acceleration is negative 9.8 meters per second squared. That's due to the force of gravity. The initial velocity is minus 10 meters per second because we're throwing the ball downwards. And the initial height of the cliff is 100 meters. The height of the cliff is 100 meters. That's the initial height of the ball. So let's start with acceleration. A of t is minus 9.8 meters per second squared. So acceleration is equal to s double prime of t. So let's integrate s double prime of t with respect to t, and we're going to get integral of negative 9.8 dt. That gives us s prime of t is negative 9.8 t plus c. That's because negative 9.8 is a constant. It passes through the integral. And we integrate 1 dt. Integral 1 dt is just t plus c. All right. So now this is the velocity. Velocity is negative 9.8 t plus c. But we know the initial velocity. V of 0 is minus 10. That means when time is 0, v of t, the velocity, is minus 10. So let's substitute v of t is minus 10 into the velocity function. T equals 0 into t, and we get minus 10 is equal to negative 9.8 times 0 plus c. That means the constant c is equal to minus 10. So let's rewrite the velocity function to be equal to negative 9.8 t minus 10. Now recall that the velocity is really the derivative of the position function. So if we want to find the position function, let's integrate s prime of t dt. That's integral negative 9.8 t minus 10 with respect to t. That's integral negative 9.8 t dt minus integral 10 dt. Minus 9.8 is a constant, passes right through the integral. 10 is a constant, passes right through. We get negative 9.8, reversing the power rule, and we get t squared divided by 2. Minus 10, integral dt is just going to be, integral 1 dt is t plus c. That's minus 10t plus constant, let's choose d. So that is our position function, s of t. Now we know that the initial height of the ball is s of 0 is equal to 100 meters. That means when time is 0, s of t is 100 meters. So let's substitute s of t is 100 meters into s of t, and time equals 0 into time. So that's 100 is equal to minus 9.8 times 0 squared divided by 2 minus 10 times 0 plus d. If we solve this, we get d is equal to 100. So let's rewrite the height function s of t to be equal to negative 9.8 t squared over 2 minus 10t plus 100. So this represents the initial, this represents the height of the ball, t seconds after it was thrown from edge of cliff. So the big picture in this video is that we started with s double prime of t, which was acceleration. We integrated s double prime to get s prime of t, and that's the velocity function. Then we integrated s prime of t and got the height function s of t, and that was the whole idea of this video. All right, thank you.